So, what do you want to work on today? Sure. All right, let me open up some stuff for review. When's your final? Oh, you cut out a little bit there. What happened? You still there? Because I can't see you. I can somewhat hear you. Oh, are you back? Okay, there, I can hear you a little bit better now. I still can't see you, so I'm not sure if there's a technical thing happening. Oh, weird. Oh, there you are. I got you on twice, probably because I think you went out and then came back in, so I can see you now. Okay, let me open up. We want chemistry. Okay, so we have some time. All right. Well, let's go through some questions today. Start with these three. Do you have a periodic table and polyatomic sheet available? Oh, you're on your phone. Okay, well that's not ideal to see what's happening, but we'll go with it and do the best we can. All right, let's take a look at these first couple questions. I'm going to have to pull up a periodic table then so that you can do this. Do you know the first question without a periodic table as to which of the following statements would be true? Would they share similar properties, have the same atomic mass, cannot react with each other, or have the same number of energy levels? While you think about that, I'm gonna pull up a polyatomic sheet. It is a yes. I'm going to paste this in because we're going to need this a little bit. So let me just pull up our data pages here and get this one. Let's go with that. Okay, so based on that first question, they don't have the same atomic mass because the atomic mass is different for every single element. They're also not going to have the same energy levels because the energy level is coming from, like, for example, if I was to do a Bohr model for sodium, what would that look like? How many electrons go in that first shell? How many would have to go in the next shell? And how many in the last shell? Okay, so this is just an atom of sodium, which is different than an ion of sodium, which we can talk about after. But if I'm looking at, say, something that is beside it, like magnesium, well then, oh, and let me just go back to what was the original question, just to make sure I'm doing this correctly. Which is true about the same, okay, so a period is the same column. So if I was to pick something in the same column, like potassium, and I was to draw a Bohr model, I'm doing the energy levels rather than a full Bohr model, we would have had 2, 8, then I could only go 8 in the third, and I'd have to go 1 to make that 19. Well, now I've got 4 energy levels rather than 3. So even within the same column, they have different energy levels. We have different atomic masses, so both of those statements could not have been true. They also would not react with each other because metals don't react with each other. You have a metal and a non-metal, it's going to react with something else. So the only thing that we do know is that down those columns, they have the same properties. Like you have alkali earth metals, you have noble gases, you have halogens, you have alkali earth metals. Those are all columns of families that are going to have the same property. So you got that. Okay, let's find out which is the Lewis diagram for nitrogen as an atom. So I'll pull up the periodic table, take a look at nitrogen. I want you to think about what would the Lewis diagram look like for that. I can even, if it's helpful, screenshot it unless you already know ahead of time how many electrons should be surrounding the Lewis diagram. No, because how when you draw a Lewis diagram, what kind of electrons do you draw? You don't draw all of them. Okay, let's do a Bohr model of nitrogen. What would a Bohr model of nitrogen look like? Right, okay, 1, 2, 3, 4, 5. So then, if I'm doing a Lewis diagram, what's the difference between that and the Bohr model? You're only putting the electrons for the outer shell. What do we call those electrons? Right, so with Lewis diagrams, we're only putting in the valence electrons, in which case I had 5 in the outer shell. So the Lewis diagram would have only 5 electrons. My circles aren't very good. There we go. 1, 2, 3, 4, 5. And so therefore we should have picked D. Okay, so when you're doing the Lewis diagrams, as an atom, whatever this is, that's how many electrons you have, but you're only looking at that outer shell. If, however, let's say it was a nitrogen, let's do another one. Let's say it was a nitrogen ion. Doing an ion of nitrogen, how many electrons would I have had to do? Okay, well, we had 7 within the atom because if it's an atom, however many protons you have coming from here, that's the same number of electrons. But with an ion, we have to take into account, what is the ion charge? It's a -3. Exactly. So an ion would only have 4 electrons. Thinking about a Bohr model of a nitrogen ion, then it would have still 2 in the first shell, but only 2 in the second shell. So as a Lewis diagram, if it asked you for a Lewis diagram of nitrogen, you would simply have the 2. Make sense? You're like, somewhat okay. Yeah, I didn't like chemistry. Okay. All right. How many protons does an atom of silver contain? So let's go to the periodic table. You're looking for silver, and how many protons does it have? It's over here. I'm just kind of circling where silver is because I know you said you're on your phone, so it must be small. Yes. Because as an atom, whatever your proton number, well, it asked for protons. It would have been the same electrons, but this asked for protons. So yes, it would have been 47. Okay, let's try some more. You minus it only from the number of protons. Yeah, whatever the mass is minus the protons, that's your neutrons. Okay, where did my page go? Let's do some more, pull out some more questions here. Let's take the next three. Oh, I already opened a page. Let's use that one. Okay, what does a Lewis diagram show? Unpaired electrons, valence electrons, electrons from the innermost energy level, or all of the electrons? Yes, and we just talked about that, so I was happy you got that. Okay, an atom is found to have 7 valence electrons. To which family of elements does it belong? So think about that. If it has 7 valence electrons, what's the atomic number? It would be 9, right. So then if we look at, okay, the atomic number of 9, which family of elements is this? Oh, and that was unfair because I didn't quite get the element screenshotted down below for you. So this would be given on a test. As long as you can identify that it's 9, I kind of cut that off. That was supposed to say halogens down here. Noble gases are at the end. So that's my bad. Yeah, that should be on here. I don't know why I screenshotted that and missed it. Okay, so yes, but you did get that part right. So we would have been looking for our halogens. All right, what is the nucleus of any atom except hydrogen made up of? What is found inside the nucleus of an atom? You got it. Because it's the electrons that float outside, right? They're in those energy shells. Good. Okay, let's go on to the next section and give you some more. Okay, we're getting into some naming stuff. Bring that over. I'll have to try to go back and forth, I think, with that periodic table since you don't have one. Do you have a pen and paper? Okay, so it might be helpful for you just to write this out, Fe2O3, so that when I put up that periodic table, you can tell me the name, and then we can come back to the multiple choice options. So what is the name of Fe2O3? Can you see that? I can write it out bigger if you want. Fe2O3. Oh, we're on the move. Okay, so you got the name written down. Here's your periodic table. What is the name for Fe2O3? FeO is a different formula, right? The formula is given. This is the formula. What would be the name of that? Okay, and so when I write Fe3O2, how do I write Fe3O2? Do I put 3 or do we write it here? Which one would you select here? The first one, right. And the reason, because Fe, our iron, was multivalent. You got it. And therefore, we had to say which charge did we use. How do we know it was the 3? Because the 3 attached to the oxygen. They have to swap places. Oxygen had a charge of 2, so that's why it's here. Okay, what is the name of S2O3? You want to write that down, and I'll go to the periodic table. S2O3, okay? Do you want to look at the options, or do you know how to do this one already? Okay. Oh, I think my camera turned off. Weird. Here, let me try that again. Off and on. Heck. What is a covalent compound? Yes. And so what do we need with covalence? Yes. And that's why when you probably looked at it, you're like, well, oxygen's a 2 and sulfur's a 2, so this doesn't make sense, right? But it's because it's covalent, it doesn't really matter. We just need to look at what those numbers are to use the prefixes. Okay. Meat can't use the camera. Why? I'm trying. All right. What is the correct formula for the compound that contains magnesium and phosphate? Now, phosphate is a polyatomic, so I'll need to pull up the polyatomics. I'm trying to multitask and figure out why my camera is just completely shut down, as I will pull up your polyatomics first. And try to screenshot that. Okay, weird. I need to bring it over because it's on a smaller screen, and every time I scroll it like bypasses the whole page. No, I didn't screenshot it. Okay. Okay. Well, we're going to need it on future questions, so I'm going to just put it on a page that I can easily go back and forth to, because we're going to get into reaction types and balancing and all of that. So now that I don't need that, let's just minimize that. We'll put it here. It'll give me a quicker access. Okay. So we were looking for magnesium phosphate. Which one do you think we should be selecting? Yep. Okay, so Mg had a charge of 2, phosphate has a charge of 3, exactly, so we need to swap them, so the correct answer you would select is... Good. Okay, let's try some more. Sorry, I don't know why my camera just shut off. I'm like, yeah, it's bugging me. Let's scroll down to these ones too. I do have another app. I'll try in a second to see if it'll work. Okay. Oh yeah, this one I saw the other day. I didn't really make sense with this one, so I might skip this one because it says which compound has no covalent bonds. Well, if you don't have a covalent bond is a metal or a nonmetal and a nonmetal. So if you have no covalent bonds, that means we're looking for something that has a positive charge and a negative charge. To me, that's how I interpret that. If there's no covalent bonds, then you have ionic bonds. And so the confusing part to me is that this is an ionic compound because sodium's a positive, sulfate's a negative. Potassium's a positive and chlorine's a negative. That's another ionic bond. Same thing with this one. So all three of these were ionic, and this one was the covalent. So it didn't make sense to me because you can only pick one, so I don't fully get that. So I'm going to choose to ignore that and go, what is the name of PbSO3? For SO3, yeah. Do you want me to go to the other one? Okay, so PB had a choice of 2 or 4. Let's look at our multiple choice options. If SO4 has a charge of 2, if we had taken the PB charge of 2, there would be no 2's at all. They would have canceled each other out. So let's look at what we have here, which they did. Actually, this is an SO3. Were we looking at SO3 or SO4? Yeah, it was. So both the 2's canceled out, which therefore the answer would be what? Not A, not B, because you have to have a Roman numeral. The fact that PB, where'd it go, is multivalent, you have to have a Roman numeral to say, well, what charge are you using? There's a couple other giveaways with this, in that we know SO3 stands for sulfite. None of these say sulfite. You can't have 3 names, sulfur oxide. Sulfate is SO4. You can't have a sulfur oxide. This is a polyatomic. The only thing that says sulfite is this one. And the other piece is that you're giving the Roman numeral because you need a Roman numeral for a polyatomic. So those are the 2 giveaways for that. Ooh, somebody's in trouble. Okay, let's go on to the next page. Oh, that was you. I thought you were talking about sister. Does she know you're on a call? Okay. Well, hopefully she'll give you some leeway till after tutoring. All right, let's pull up a few more questions. All right, let's try these ones. Oops. Okay. Which statement best fits the accepted model of an atom? Are electrons associated with specific energy levels surrounded by the nucleus? Is an atom a sphere of positive charge in which electrons are embedded? An atom is a small indivisible sphere. An atom has a nucleus surrounded by positively charged particles. What do you think for that one? That would have been my closest, probably second guess. It is a sphere. It does have a positive charge in the center. Electrons are not embedded. Electrons are surrounding the nucleus. So if it were me, I would say with, yeah, A, the electrons are associated with those energy levels, whether you have electrons in the first shell, the second shell, third shell, but they surround the nucleus. Okay, when metal atoms form ions and compounds, what do? Do they gain electrons? Do they lose electrons? to form positive ions, or do they gain or lose to form negative ions? So if you think about it, let's just pick some as an example. Let's say we choose, I'm going to go with aluminum and I'll go with aluminum and sulfur just because they're close to remember. Al2S3, let me just take that one for a second. Al2S3, okay. So, 3. This had the charge of +3, this had a charge of -2. What is happening when the metal atom forms an ion in a compound? What is this metal atom doing? Is it gaining electrons, losing electrons? Now, writing a compound might not be the easiest to solve this. In fact, I would almost suggest, I have an idea. In fact, I'm going to take one of your previous test questions. Give me 2 seconds to pull this up because I just finished looking at it before I saw you. I don't know, my mouse, I'm having technical difficulties today. My mouse is not working, my camera's stopped working. I'm using a drawing tablet as my only means of moving my control pad around. I think I probably need to restart my computer, but I can't do that now. So let me go to my downloads and look up that last test you did again. Okay, it is opening up. I want to give you a question, which is, come on, load for me here. This will work. Potassium nitride. This was your question. You got the right chemical formula. You wrote it as K3N. So that one you got right, because if we look at it, potassium has a charge of 1, nitrogen has a charge of 3. You did swap those charges. That was a correct, which is ionic. Metal, non-metal. Now let's say we were to draw it looked like you had to do the Lewis diagram. If I was to do the Lewis diagram, again, Lewis diagrams, we only draw valence electrons. Just to make this a little easier, I'm going to screenshot each of these so we don't have to come back and forth. There's potassium. And let's pull up nitrogen beside it. Okay, let's draw the Lewis diagram for this. How many valence electrons does nitrogen need? Okay, so on nitrogen, I'm going to draw 5. 1, 2, we go clockwise, 3, 4, until we start pairing up. How many valence electrons is potassium going to have? Right, so for this one, I also need 3 potassiums. So I'm going to have a potassium here, I'm going to have a potassium here, and here, and they each have 1. Whoops, I should have put it there. It's getting a little off-centered there. So when you end up with 1 from each joining together, what we do is we now form them with a line. So there's going to be a line to the nitrogen there, a line this way, a line this way, and the 2 free elements, or free electrons, up top. That's what a Lewis diagram would look like. So in order to answer this question, when an ionic compound is formed, are we losing or are we gaining electrons to form that? Are we forming a positive ion or a negative ion? Yes. Are we losing or gaining? Yes. Good. All right. How about if, oh look, and oh no, that's not aluminum. I thought I just screenshot aluminum because I wrote it up here. If we have aluminum with a 3+ ion, how many electrons and protons does it have? So I'll pull it up. Here's aluminum. Where's aluminum? Here. How many protons and electrons does it have? Thirteen protons, yeah. If I was to add 3 more to it, then that would make it 16, but now I'm overtaking, that would have made a -3 charge. I want less charges, right? If you've got a +3 charge, that means I need more protons than I do electrons. It'd be 10, right? So if your charge is plus, you take it away for the electrons. If your charge is negative, like here, that means I have an overall negative charge. I need more electrons. Yes, it would be then 18 electrons with 16 protons. Okay, so yes, so this would have been 13 protons, 10 electrons here. Okay, good. All right, let's go on to some more. Review final here. Oops, I did something there. Let's scroll down. Okay, let's try some of, well, I'll do one here. Listen, I'll do another one. Okay, so this one, which, oh, I did it again, I think. Nope, I keep pasting on the wrong page. Okay, this reaction of solid copper to oxide with hydrogen gas produces copper, metal, and water. Oh, I accidentally cropped out D. Which chemical equation reaction represents this? So the first thing that we would want to start with, what's the equation or what's the formula for copper to oxide? Yeah, because you know oxygen has a charge of 2. So if copper's telling you to use a charge of 2, those 2's are going to cancel. So even though you can't see this, it was started with a Cu2O, which we know we can't happen. So you've eliminated it to that it has to be C right off the bat, just from that first piece. Never mind the fact that hydrogen should have a subscript 2. This one didn't. Why would hydrogen have had a subscript 2? Wonderful. Do you know all your diatomics? Okay. Uh-huh. Wonderful. Have no fear of ice cold beer, right? All of these ones down here, have no fear of ice cold beer. It's in different order. Or think of it as the zombie. That's your zombie head, and there's your body with its arms out. Those guys there. Good. So again, that would have had a subscript. It produced a copper metal. Copper's not diatomic, no subscript 2 plus water, and then it's already pre-balanced. So that was it for there. Okay, let's go on to, where did it go? Nope, that's your old test. I wanted this one. Okay. All right, let's get into some more formula stuff here. I got room. Let's put them on this page. Okay, which name and formula match correctly in this one? We've got magnesium fluoride, sodium sulfide, aluminum iodide, iron 2 oxide. Which of these is correct? So you're going to need a periodic table for this. It might be easier, in fact, if I just take this question and put it beside the periodic table. I'll just put it up here for now. Aluminum iodide. Iodide, the fact that it ends in IDE tells me it's a single element. Polyatomics don't end in IDE, like phosphate, phosphite, carbonate, carbonite, just any of those. This is a single element. IO3, there's no such thing. it would have just been A, magnesium and fluoride. Magnesium had a charge of 2, fluorine had a charge of 1, they've swapped, and voila, that's it. Yes. Okay, let's go back. Okay, what is the formula for aluminum carbonate? Okay, just as I finished saying, these all end in an IDE. Those are single elements, so that's why it couldn't be this. This does not end in IDE. It ends in 8, carbonate. That's a polyatomic. Aluminum carbonate. So let's take a look at it. What's the charge on aluminum? Okay, what is the charge on carbonate? Okay, so if we have a +3 charge for this, but a -2 for this, what's the correct formula? Yes. All right, how about what are the coefficients that we would need to balance this equation? What is not balanced right now that needs something? I'll try disconnecting my camera as you think about that for a second. Chlorine is not balanced, right? So what could I do to balance that? Yeah. Good. All right. Let's try that. Oh, I think I may have action. I unplugged and replugged my camera in. It's like giving me lights. It might be thinking that it wants to turn on. All right, let's get into writing chemical formulas. Come on here. Now my screenshot's being difficult. Oh my gosh, I get one thing to start working and the next thing doesn't. Okay, fine, be that way. Really? I'll try one more time. If not, I'll write them. Oh, I think that worked. And now my screen just went black. Where is it gone? What just is happening here? Oh my goodness. Technology is not my friend today. Oh my word. Okay. Not cooperating. I wish you had a periodic table, because then I could just, like, as I'm trying to get this to run, I could have told you what to do. Okay, then try that for now while I try to get this running. I might have to exit it and reload. What would the formula be for potassium nitride? I'm going to just try reopening this. My internet connection is good, so what the heck. Potassium nitride. Yes. Good. Okay, what about lithium oxide? Maybe if I turn my camera off. Li2O. Lithium has a charge of, yes, good. How about iron 2 sulfide? And I'm just going by my memory of elements since this is not cooperating. Good. All right, now that I seem to have lost everything entirely, including my Google Meet, I don't know what's happening. Let's just